Welcome back to this tutorial about making animations in Grasshopper. This is the second video in this short series. In the last one, we talked about how useful animations are, phenomenally helpful in conveying ideas, and the fact that with Grasshopper, we've practically already got animations right at our fingertips. Grasshopper is all about changing inputs to change geometry, so if we can just trigger our inputs to change at some intervals of our choosing, we've got an animation. So in part one, we made a component to do just that, to trigger changes at regular intervals. If you haven't already seen that video, you might want to jump back over to that one. But with that said, let's just go back into Grasshopper. I'm going to make this window a little bit smaller so we can see Rhino, and let's start by let's click on this rectangle component, this rectangle tool right here. I'll click Shift just to make a square one. Let's pull it over here. It's fine. And I'm going to get rid of the grid. Then let's go into the Grasshopper, and I'm going to get a curve component, and I'll say set one curve, that one. I'm going to right click and say internalize data, so I can delete this. Or let's not delete it. Let's just delete it. That's fine. Let's make a little component that arrays this in the X and Y directions so that we have something like a grid. First, let's scale this just a little bit, make it a little bit smaller by a number somewhere between 0.25 and 1. Call this scale. And let's set the center to the center of this curve. So I'm just going to get an area component, and that's going to be the center of the scale. And then let's get an explode component so we can measure the size of this original square. I'm just going to get a list item, and we just want to know what the width of this square is. So if I get a curve length, and this is going to be helpful so we know how much to move each time in the X and Y directions. Let's get a series. That's going to be our step. That's how much we're going to go at each time. And I'm going to get an integer, call this count, and a number slider between 2 and 30. Go up to like 7. And then move. We want to move it in both the X direction, so I'm going to get unit X, and the Y direction, unit Y. We'll just make this a square grid, so we'll move it in the same amount in both directions. First we can move it in the X direction, our scaled one, then right click and go to graft, and I may as well just simplify it here, copy this, then we'll move it in the Y direction. So now we have a grid of squares. Hide all of this. Output. We don't need to simplify. We'll flatten this instead of graft it. Put that in a component that we can call array. And then let's make these all into like three-dimensional rectangles, rectangular prisms, or whatever you want to call them, just so we can run an animation where these grow at different rates. We want different heights for each one of them. Our quick way of doing that right now can just be to start by getting the center points for all of these, deconstruct those center points, add the X and Y coordinates together. We'll square these, and we'll call this output in heights, and let's get a cluster output. And one more thing we can do right now, since we already know how many items we're going to have, we have 49 right now, 49 different objects, so we're going to need 49 different counters. So let's say list length. That's going to be our number of counters. So I'll say wire display faint. We don't need that 5 anymore. So these are going to be the maximum heights each of our objects gets to, but as I hover over this, I can see that it's going up very high, like 1600, 1641 is the last one in this list. So we might want to get a multiplication and scale these numbers down a little bit. So I'll get a number component, and let's just call this adjust height. And it's called be in heights. This will be adjust heights. And this is going to be a number between 0.001 and 1. Actually, it's probably not going to have to go up nearly that high. We'll say to 0.2 will be the maximum. So I'm going to copy this, label our slider, adjust heights. Also, these are going to grow with time. So I'm going to get another number component and call this one time. And this is going to come from all of our numbers here, or all of our counters here. But since these are all set to 0, we don't actually want them to be 0. We want them to be very tiny, but not quite 0, because they won't actually be breps then, or they won't actually have any height, and that makes it a little bit messy when we're doing this animation. So let's make them, instead of having a height of 0, let's give them a tiny height. So I'm going to get a construct domain, and 0.01 we'll just start the height off there. And let's say remap numbers. So instead of going from 0 to 1, we want them to go from 0.01 to 1. So that can be our time instead. Bring these over here. And our curves, let's get an input curve component. Call these our bases. We're going to move these in the z direction and then make breps out of them. And let's get a multiplication. So now we have the actual heights. Let's get a move component. Let's actually move these up so we can adjust this a little bit. How high do we want them? Maybe something like this, 0.012. So we'll make the max 0.02. The way we have, and we'll put 4 levels so we can have a little bit more control over how high these go. But we don't want the height to come out of here. We want it to actually be driven by time. So that can go into our z. And then let's reset and just see what it looks like. Let's increase the speed here. And we'll decrease the wait for, reset. Okay, you get the idea. It's kind of, they're all growing at different points in time. So let's get an entwine component. Put that in there. Say simplify, and then we'll flip this matrix. Because right now we have 2 branches, each with 49 different objects in them. But we want 49 different branches, each with 2 different objects in. That way we can say loft each of those branches. Let's simplify again, and let's get a merge component. And a surface. We'll get this is the top curve, so we'll make our top curves into surfaces. And then let's graft and simplify this. Now we have 49 different branches, each with 1 surface. Here we have 49 different branches, each with 1 brep. We'll merge those so that they're together in their branches. So 49 different branches, each with 2 objects in them now. And we'll say brep join. Join is with a J. And let's hide all of this, including our bases, and we don't need anything over here actually, we'll just hide everything, except for our breps. And we can flatten the breps. I'm going to pull all of this over here. So what do we need if we're going to make this into a component? We have our adjust heights, our in heights, our bases, and our time as inputs. That's good. And what do we want to bring out? we actually will want this number before we multiplied it by time. This tells us what the maximum heights will be, and this is a way that we can, when we're applying color to these, we'll be tweening between two colors. We'll be going between two colors, and this is a way to set the value, set those bounds, because we know that these will be the maximum that we'll get to. So we'll say output, and we can call this output set bounds. And then this can be our out height. And so the colors can actually change as our heights change, so we'll get another output. And then our breps can be an output too. Say breps. So let's collect all this, cluster it. We can call this component getBreps. And then all we need to do is apply some colors to these if we want. So I'm going to get a brep edge component. And it might be nice to see the edges of these. I'll merge these two. We have naked edges and interior edges. We can just flatten these outputs, both, put them into the same component. We're just getting these so that we can visualize them. And then, so we'll just get a custom preview. These are our geometries and color swatch. We'll make them close to black. And then, as I mentioned, we'll remap the numbers coming out here based on what the maximum height will be. So let's get a bounds component. So we're going up to 14.9, and that's going to be our target here. Or, sorry, not our target, it's going to be our starting point. And our target is going to be however many colors we have. So I'm going to get a merge component, and we can put as many colors in here as we want, and we're going to tween through these colors. So if you have the Pufferfish plugin, a handy component to have is the tween through colors component. If you don't have the Pufferfish plugin, I'll link to that tutorial on how to install that. So with this component, all we need is a list of colors, a list of factors, and the factors are basically just a list of numbers, and depending on, so let's say we have 3 colors, that's going to go from 0 to 1 to 2, 0, 1, 2. And so if the factor is 0, it's going to be this first color. If the factor is 1, it'll be the second color. If the factor is 2, it'll be the third color. If the factor is anywhere in between those, it'll be some color in between those. It tweens through them. So let's get 3 colors with our color swatch. Like that. This maybe a little bit later. So now we have 3 colors, and so that we can quickly change the number of colors. If we want to add another color in here, we'll just use a list length and say subtract 1. So 3 minus 1 is 2, and so that's because these are going to go from 0 to 1 to 2. So that's what we want our bounds to be. So I'll say construct domain. We want this domain to go from 0 to 2. So this is actually going to be our target here. And where are the values going to come from? They will be our heights. So as each of these breps gets taller and taller, it's going to change color. And what the mapped values that are coming out of here are going to be our factors. The colors are going to be coming out of this merge component. So now we have 49 different colors coming out. So we can get another custom preview. These are going to be our colors, and the breps are going to be our breps. And now we can play our animation. Okay, scroll down here, we can see the last number in the list has gone to 1, so the animation's done. If we want to change how these are colored, we can right click here and say reverse list. So that's it for this video and for this animation. Maybe you've already thought of all kinds of ways to apply the methods here to your own work. If you'd like to see a slightly more complicated use of this tool, stay tuned for the next video in the series. In that video, we'll be making this animation. And if you want to download any of the files from this series, just head to the Pavilion. The link to that is in the description of this video. So as always, thanks for watching, and we'll see you next time.